Hi and welcome to this topic, the mass of substance. So this topic is very mathsy and it's usually the one which separates out the chaff from the rest of you who will hopefully pass. If you don't like maths, you're not going to like this, but everybody should love maths. It's nice and clear, black and white, right and wrong, so numbers are your friend. They should be guaranteed marks. Provided, of course, you can use chimp fingers and use a calculator correctly. There's a couple of definitions which you need to know first. Up here, definition for relative atomic mass. That's the simplest definition I think I can give, which would still apply to all exam boards. So the average mass of one atom divided by 1/12 the mass of one atom of carbon-12. So this bit here is what the relative refers to. Everything is relative to carbon-12 in the periodic table. You need the average up there to take into account isotopes, which I said last video, because there could be chlorine-35, 37, etc. So it's usually 2 marks for this definition, 1 mark for the word average, and 1 mark for this bottom line getting in the 1/12 of C12. If you're going to use moles in there, make sure it's mass of 1 mole of atoms compared to 1 mole carbon-12. And if you want to change that definition to make it relative molecular mass, all you do, rather than talking about 1 atom, you talk about 1 molecule. Leave the rest the same, 1/12 C12. So fairly straightforward, should get you some guaranteed marks. Now this topic deals with a mole. The mole is just a posh word for a big number, just like saying a dozen rather than 12. The mole is defined by Avogadro's constant. It's the amount, so this across here, so 6.022 times 10 to the power of 23. Huge, 6 billion, 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 etc. So a mole is the amount of substance which contains that many particles. So if you've got twice as many particles, then obviously twice as many divided by that is going to give you 2 moles. If you've got 5 times as much as that, you're going to have 5 moles. If you've got half as much of that, half a mole. So you do need to be aware of what the mole is, although you never get asked questions based on that calculation. Now a few of the other equations you do need to memorise, by the way, you are not given them. So I'll start off with the easiest one, the solid across here. Moles equals mass over atomic mass, or mass over molecular, or mass over formula mass, depending on what you're dealing with. If you are mathematically inept, really, and struggling with rearranging equations, you should get the hang of them quickly. It is an important skill, but there is a way to help you with this. You can put them into a triangle. Like that. And whatever you want to work out, just cover it up with your hand. So if I want to work out mass, I do moles times AR. If I want to work out moles, if I want to work out the atomic mass or molecular mass, I do mass over moles, etc. Nice and easy. So an example here, if I've got 3.14 grams of the ammonium sulfate, then I'm going to do mass divided by the formula mass of this. So I need to work it all out. So I've got 18 in here. Remember to multiply everything in the brackets by 2. Plus sulfur, 32.1. Use the decimals on your periodic table. And then the 4 oxygens. So if you do that, you will get so 0.0238 moles, 3 significant figures. If I've done that wrong on the calculator, apologies, correct it. I will always shout at people to do calculations 2, 3, 4 times, however much time as you've got. I just don't want to be standing here in front of you doing it over and over. So that's a solid one, very easy. Next one, we will look at solutions. So solutions, moles equals concentration times volume. You should know the units for these. So concentration, moles per decimeter cubed, i.e. it's a measure of density really. How much stuff is packed within 1 dm cubed. So how many moles within that? So if you've got 10 moles within 1 dm cubed, it's obviously more concentrated than if you've just got 5 floating about in there. Because of this dm cubed, volume must always be in that. People will typically drop marks by forgetting to convert cm cubed into dm cubed. To convert that, you do cm cubed divided by 1000 will give you that. So a question here laid out. So this is sort of a very exam-y style. 40 cubic centimetres of a 2 moles per decimeter cubed solution of sulfuric acid was required to neutralise 30 cubic centimetres of sodium hydroxide. Calculate the concentration of sodium hydroxide. Now, first thing to always do with these, write out the equation and balance it. So the HCl, NaOH, things like that you're expected to know. If it is compounds which are unfamiliar to you, you'll be told the products and then you'll just have to balance it from there. So here, 2 sodiums on this side, 1 across here, so I'll double this. Sulfate, sulfate, that's fine. I've got 2, 3, 4 hydrogens there, only 2 across here, so I'll double that. 2 oxygens there, 2 there, that's fine now. Balancing equations is a skill you must practice on. There is no step-by-step method to going through them. There are some tricks to make it easier. Like you saw me, I just went sulfate, sulfate, left it at that. So I didn't bother counting the amount of sulfurs and oxygens. But it is just something you need to practice, really. It's just chaos in your head, making sure every atom is the same on each side. Right, now what I typically get people to do is to lay this out in a table. So like that. So you can start putting the information you know in here. N stands for moles, by the way. I know you'd probably think it would be M, but can't remember why. It's M. So we're going to be using this equation, but we need to fill in the information what we know first. So 40 cm cubed, what do I need to do to that first? You should hopefully have memory longer than a goldfish. I need to convert it to dm cubed. So I'm going to divide this by 1000. Likewise, I've got a volume of sodium hydroxide. I've got a concentration of sulfuric acid. And that is all I know. I can work out the moles, which I'm going to do in a second. Don't know the moles of that. Don't know the concentration of that. This is my final goal to get to there. So I'm going to use this equation, moles equals concentration times volume, because I've got a concentration and I've got a volume. So 2 times 0.04. So 0.08 moles of sulfuric acid. Now this equation, the reason why we had to balance it is because it tells us important information. It tells me 1 mole of sulfuric reacts with 2 moles of sodium hydroxide to give me 1 mole of sodium sulfate and 2 moles of water. I.e., if I have 5 of that and it reacts fully, I need 10 of that. If I have 50 of this and I want to react fully, I need 100 moles of this. So the question says it was neutralised, so we did react it fully. So 0.08, I therefore need twice as much. So when things are reacted fully, whichever species has got the bigger coefficient here, so the bigger molar ratio, should have more moles in there. So likewise, if I was working backwards and I knew this but didn't know this, because this has got the bigger number, it should be telling me I need less moles of sulfuric. So what it means is the sulfuric is a strong acid. I need 2 sodium hydroxides to come along to take out one of these big strong fellas. So now I know the moles and I know the volume. So I'm going to rearrange this equation. I'm going to do moles divided by volume. Again, if needs be, you can have a little baby triangle. like that. So whichever one you want to work out, I want to work out concentration, so I do moles divided by volume. So 5.33 moles per decimetre cubed to 3 significant figures. So there's your concentration of sodium hydroxide. The method does work as well if you are putting a solid in to react with something. So if I chucked some sort of solid acid into the sodium hydroxide, as long as I know how many moles of the solid I'm putting in, then the ratio does still apply. And then you can work it out from there. Right, next bit to look at, I'm going to do the ideal gas equation. So again, you need to memorise that, you need to know what they stand for, and you need to know what units they should be in. But as long as you know that, afterwards it's usually just a case of monkey plugging in numbers, and it's guaranteed marks in my opinion. So P stands for pressure, should be in pascals. V stands for volume, this one should be in meters cubed. N, number of moles. R is the gas constant. Always 8.31. You usually are given it in exams, but do not push your luck. One number to remember, R is always that. T is temperature, and temperature should be in Kelvin. Now, how you convert Celsius to Kelvin? There. And in case you're curious, the volume so it's a metric scale. dm cubed divided by 1,000 gives you meters cubed. Right, I'm going to do a question from A-level chemistry, so a very good website, lots of resources, get on there. It is the ideal gas paper in there, and it is question 7 I'm going to look at. Right, so that's the question, and it asks me to calculate the volume of nitrogen dioxide produced. Now, if it's asking you volume of a gas, you should always click straight away ideal gas equation, write that. Exams, you usually get 1 mark from writing that. Even if you have sod all idea what to do afterwards, write the ideal gas equation, get 1 mark. So, in terms of attacking this question, we can see we've got a temperature which we could convert. So we've got that. R is constant, we know that. We've been given a pressure here. We can convert this to pascals just by timesing by 1,000. We are looking for the volume, so we don't know that. Do we know the number of moles of nitrogen dioxide? No, at least not yet. The way to find this out is again using ratio. Across here we are told 10 grams of calcium nitrate, so 10 grams of this material. Now look at the equation. 2, 2, 4, 1 ratio tells me if I react 2 moles of this, or it decomposes rather, it's not reacting with anything, I will get 2 moles of this, 4 moles of the nitrogen dioxide, and 1 mole of this. i.e. however many moles of this decomposes, I will get twice as many moles nitrogen dioxide. How do I work out moles of this? Well, I know mass, and I can work out the relative formula mass. So do that first. So it's going to be 2 times calcium, if I remember right, and then 2 times everything in there. So 16, 32, 48, 52, 62 times 2. So that's it as a fraction or 0. If you prefer decimals. So once we've got that, like I said, we're effectively going to be dividing by 2, timesing by 4 to get the moles of the nitrogen dioxide there. Now we need to rearrange this equation to make V the subject. Simple as that. Now just plug your numbers in. Right, so we've got 300 plus 273.15, the conversion, remember. Divided by your pressure, 100,000. And you can do that on a calculator. Once you do that, that will be your answer in meters cubed. And that is the ideal gas equation. That's a fairly tough one for being able to use it. If I asked you to work out the the volume of oxygen, simplest way, 4:1 ratio, you will produce 4 times less. You could go through it again, working out the moles of this, 2:1 ratio, so you'll produce half as much moles, and then doing the calculation again. Either way, you would work it out. So far, define relative atomic mass, relative molecular mass, solid calculations, solution calculations, ideal gas. Next video we will look at atom economy, percentage yield and empirical and molecular formulae. Thank you.